All right, well, welcome once again to my advanced algebra students, and we're ready to go on. And this is really kind of go on. We're actually going to enter into 13.4. We've been in 13.3 for quite some time, looking at those trig ratios, the sine, the cosine, the tangent, and as you figured out, we learned a lot more than just what the book had in 13.2 and 13.3. And the reason why is a lot of what we looked at that went beyond the book was reviewing what was in geometry. But it's really important that you understand those trig ratios in order for the trig functions to make sense. So now we're going to start looking at the trig functions, and we're going to start by looking at the sine function. So the sine function comes from the sine ratio, but we're actually going to consider it to be a function where we have an output that changes based on the given inputs. And the output of the sine function is going to be the ratio. In other words, what the comparison of the sides is. The input is going to be the angle. So let's see if we can understand this. So the first thing here is when we look at the sine of theta, the y value, the sine of theta, when we talk about what the answer is, we're talking about the y value on the unit circle at theta. So if I made a circle, which we call the unit circle because I make the hypotenuse 1. And now what you're going to want to do is understand this the best you can, but also understand that you don't have to be really familiar with this in order to work with it. So learn the rules and you can work with it. So what happens is the y value, the distance up, that becomes the opposite side over the hypotenuse, but the hypotenuse is always 1. So it's just whatever the opposite side is, that is the sine ratio. If the hypotenuse is 1, because it's always opposite over hypotenuse, hypotenuse is 1, so it's just the opposite side. And if I make a triangle anywhere, the opposite side just becomes the y value. So what happens is, when instead of thinking of the unit circle, I now put it into the xy plane, but x is not the x coordinate, x is the angle. It is the theta. Then what happens is, I get a graph that looks like this. And let me just kind of walk you through it. You might want to pause the video and sketch the graph. But what happens is this graph becomes a function y of the sine of x. But the x here is theta. It is not the x coordinate. So what's happening here is when I'm at an angle of 0, my opposite side, my y value is 0, so I'm here. So at theta of 0, I'm at 0. Then as I start to advance my theta, my y values get bigger. So notice if I go and I advance my thetas, my y values get bigger. Eventually, when I get to pi over 2, my y value is 1, because remember my hypotenuse is just 1 of my circle, so it gets up to a value of 1. And then as I keep going beyond pi over 2, which is the equivalent of 90 degrees, I keep going beyond that. Now my y values start to decrease, so they start to go back down. When I get to a value of pi, that's 180 degrees, notice my y value is back to 0. So there's my y value back to 0. And then as I continue to go beyond pi, notice now my y values go negative. So see here my y values go negative. When I get to this angle here, 270 degrees, or 3 pi over 2, my y value is negative 1. So that's what I'm down here. That's the lowest the sine value will get. And then as I continue on, the y values start to increase. They're still negative, but they start to increase. So here I have them increasing till I get back to 2 pi, which is 1 full circle, 360 degrees. I'm back to 0. And the whole pattern starts over again. So we see it as this periodic function. We talked about periodic functions back in section 1. If you remember, over a given amount of time, it continues to repeat the exact same pattern. So let's look at some characteristics of this sine function. So first what we see is in the function y equals sine of x, Y is the value of the sine ratio. So it's the value when I compare the opposite side to the adjacent side. X is the angle theta. That's one of the hardest things for students to remember, is the X is not the X coordinate from this unit circle. The X is actually the angle theta. So the input to a trig function, in this case the sine function, is an angle, because we're always taking the sine, cosine, or tangent of an angle. Remember, it's always what's the ratio of sides for a given angle. So the input is always that angle. All right, so some characteristics of this. The first characteristic, the first thing we have to know is called the amplitude. And what is the amplitude? If I look at the sine function, and one of the ways we could transform is we could multiply the sine by something, A, or we could multiply our x value or our theta by something, call it B. So in this equation here, the amplitude is the absolute value of A. And what that does, you should know from your characteristics, that's a vertical stretch. So the amplitude basically, or the absolute value of A, is how much it has been vertically stretched. So for instance, if I multiply this by 2, this would stretch by 2. So instead of being 1 at pi over 2, it would be up here at 2. And instead of being at -1 here, it would be down at -2. If I multiplied it by 3, it would be stretched up to 3, and so forth. So this changes the vertical stretching, but does not change the length of the period that it takes to complete the cycle. So here are some important things. The amplitude, the number, means the distance from the midline to the maximum or minimum value. So if my amplitude is 2, then I will be 2 from the midline, which in this case would be the x-axis, up to my max or down to my min. So that's my amplitude. It measures what we call the energy of the wave. The bigger the amplitude, the more energy that the wave has. Okay, the period. Remember, the period is the amount of time. If I scroll up here, see if we can keep our graph in view for a little bit longer. The period is the amount of time it takes to make a complete cycle. So notice here, it starts here at 0, goes up, comes down. Now it gets back to 0 here, but it hasn't made a complete cycle, because all it has done is gone up and come back down. It doesn't finish its cycle till it's gone down and come back up, and so it takes 2 pi to make a complete period. So how do we find that from the equation? Well, in this equation, the way that we find the period is we have to use this B, because the period is affected by the horizontal stretching or shrinking, so it's affected by B. So if we take 2 pi and we divide it by B, we get the period. So in this equation up here, we had y was equal to sine of x. Well, the B is 1. So if I take 2 pi divided by 1, I would get 2 pi. So this one had a period of 2 pi. So what is the period? A reminder here, we talked about this. The period is the time that it takes to make one complete cycle. And it doesn't matter where you started. If you started from here and go till you complete a cycle, it's still 2 pi. So from pi over 2 to 5 pi over 2, it's still 2 pi. If I start it down here from negative pi over 2 to 3 pi over 2, it's still 2 pi. That's how long it takes to make a complete cycle. All right, let's look at some examples. So here's 13. And so what it's asking you to do here is it's asking, I need to open up my book to make sure I've got exactly what it's asking you to do so I can explain correctly. Don't want to give you incorrect information. So what it says here is it gives you that picture, and it says determine the number of cycles each sine has in the interval from 0 to 2 pi. The number of cycles here. So notice, going from 0 to 2 pi, we have not completed a cycle yet. We have only gone from the 0 up and down. We've done half of a cycle. So when we say the number of cycles, in this case, it is 1/2. And from that, we can also calculate the amplitude. So the amplitude here, and it also says to find the amplitude in the period. So the amplitude is how far from this midline up to the maximum. Well, it just goes from the midline up to a maximum of 1. So the amplitude is just 1. And the period here is how long it's going to take to make a complete cycle. So if it's made half a cycle in 2 pi, well, to get a full period in, it needs another 2 pi. So the period is going to be 4 pi. So I can get all of that by looking at that graph. And let's look at another example. Or at least let's look at if we can fill out this equation. It doesn't say to do this, but this will just help us do it. Let's see if we can fill in the equation. So we know the amplitude is 1. So we know A is going to be equal to 1. If the period is 4 pi, I know the period is 2 pi divided by B. That equals 4 pi. So if I solve this for B, multiply both sides by B, or I could think of cross multiplying. So what I did here is multiplied both sides by B and then divided by 4 pi to get B by itself. So when I do that, I get that B is equal to 1/2. So that becomes my equation. The equation for this is sine equals 1/2 theta or 1/2 x. Could think of it either way. All right, 15. So 15, what they do is they tell us the amplitude. They say amplitude is 2. And they tell us the period. Period's 2 pi over 3. And so we can calculate the values. It wants us to find the equation. Oh, I guess it wants us to sketch. So it wants us to, so we find A here being 2, because amplitude is 2. And if the period is 2 pi over 3, I can solve 2 pi over B is equal to 2 pi over 3. So I see B is 3. So I know my equation is going to be y equals 2 sine of 3 theta. So when it says sketch one complete cycle, the easiest thing for me to do is if I look here, set your scale based on this. So I know I'm going to do one full cycle in 2 pi over 3. So what I'm going to do is I'm going to start here, and on my graph, I'm just going to graph amplitude of 2. I'm going to make the top and bottom 2 and -2. And I'm going to just draw a line, a tick mark, and a tick mark, and I'm going to make this 2 pi over 3. Because I know that's how long it takes to make a full cycle, which means that it must make half a cycle, and half of that pi over 3. And now I will just sketch it proportionally. Don't worry about what these are to scale so long as you label them. So long as you label the ending one is 2 pi over 3, the middle one is pi over 3, you've got it. And you know that from your periods 2 pi over 3. Sorry, couldn't see that. That's what the whole thing looks like. Okay, your homework is to do 13.4, 6 through 26 even. So it's those even problems there, and I hope it goes well. If you need a question, shoot it to me on, or you have a question, shoot it to me on Google Classroom if you need an answer. We will have a Zoom session to answer questions next week. But if you need something sooner, let me know and we can arrange something. All right, hope it's going well.